If you were to ask scientists in the 1990s about our solar system, they would have told you that we know everything there is to know in our solar system and that there is nothing left to be discovered. However, they were wrong. In 1951, Gerard Kuiper hypothesized the existence of what would later become known as the Kuiper Belt. But Kuiper Belt objects would not later be discovered until 1992. The reasoning for the existence of such a region is that an Irish astronomer named Kenneth Edgeworth, in 1949, speculated that the solar nebula that formed the planets didn't have a sharp edge at Neptune or Pluto, which is where everyone believed the boundary was for planet formation. So if there wasn't a defined edge, then that could mean that there would be more bodies beyond the planets. Gerard Kuiper again brought this up in 1951, but said that these bodies would not be planet-sized due to the fact that their timescales for collision would be too long to form planet-sized bodies. This was, however, merely speculation and was not really followed by the scientific community at the time. The driving force behind the belt's discovery was the mystery behind where do comets come from. Comets' average life expectancy, so to speak, is about 500,000 years. Since our solar system was much older, then there had to be something feeding and driving these comets to still be around today. This question is complicated by the fact that comets can have significantly different orbital periods in relation to one another, so scientists broke them up into two categories. Long-period comets, which have an orbital period of larger than 200 years and come from the Oort cloud, and short-period comets, which have an orbital period of less than 200 years and come from the Kuiper Belt. Jan Oort explained in 1950 that long-period comets came from a spherical cloud with a diameter of 100,000 AU, which is now the Oort cloud, but it didn't explain short-period comets. When scientists began looking for the cause for these short-period comets, they turned their sights past Neptune and Pluto, and in 1992 found the first Kuiper Belt object, 1992 QB1. They calculated it at 41 AU from the Sun, and calculated it to be 250,000 kilometers in diameter. Since then, there has been 1,500 Kuiper Belt objects discovered, but there is an estimated hundreds of thousands of icy bodies larger than 100 kilometers and an estimated trillion or more comets. The Kuiper Belt itself is a donut-shaped body extending from 40 AU to about 1,000 AU. Total, the mass of the Kuiper Belt is about 10% the mass of the Earth. This mass is much larger than the mass contained in the asteroid belt, but it is still too small to form Pluto-sized bodies. This leads us to believe that the original Kuiper Belt must have been much more massive to produce such large bodies, about 10 to 100 times the mass of the Earth. This Kuiper Belt is known as the primordial Kuiper Belt. The relative speed of objects in the belt is around 2 kilometers per second, so when they collide, they shatter. They do not stick together to become larger bodies, which is one reason why we do not find any planets out there. The orbits of the Kuiper Belt objects is also very diverse. They're not uniform like the planets, elliptically speaking. They're highly organized, however, into clusters and gaps of orbits, which implies that they have been highly influenced by Neptune's gravitational field. There have been discoveries of other Kuiper Belts in the galaxy, which means this could be a universal phenomenon. There's still much to be discovered, however, about the Kuiper Belt, and there is a space mission dedicated to making such discoveries. The mission, New Horizons, is set to reach Pluto in 2015 and will begin taking pictures and acquiring data to be sent back to Earth.